Hello everybody, this video will be all about new release of Cutter version 2. This release introduced very interesting new features and you can read about these features on their website. You can see it here, or you can check it on their GitHub page. Basically, Cutter is a free and open source reverse engineering platform, and from this new release, it's powered by Rizin. You can check the new features and changelog on the latest release. What I'm most interested in is basically new feature called reverse debugging support. But there are quite plenty of interesting new features like supporting new projects in Cutter that will allow saving and opening project files. Basically, if you annotate the project in the Cutter, like adding some comments and flags renaming, function renaming, it will it will be all held in the project file. So you can load the saved project file with all saved annotated items. You can see another quite interesting thing is adding a preview on Hoover functionality in Disassembly widget. Basically, it will show you some preview of, for example, function. And what do we have next here? Improving the workflow of renaming function flags and more. Basically, you can rename more items. I will show you all later in the exercise. Okay, so for now we can jump to the Cutter. For this exercise, or for this showing of new features of Cutter version 2, I prepared one basic application. You can see it here, the print replace exe. Basically, it's replacing to string the original string for the another string, and it will be doing the replacing character by character, and it will replace the original string in memory in the same location. Basic application, but for introducing the new features, it's enough. So let's jump to the Cutter. And we can see here our prepared executable file. Okay. And we are here. Well, we immediately ends on the entry point. I want to jump to the main function. We are in the main function, and what do we got here? Okay, you can immediately see that the main function is processing some string. The strings goes here, the pointer to the string goes here, the pointer is moving to this variable. Yeah, so we can rename it to with the n, pressing the n, we can rename it as for example pointer original string. Okay, and we can see that the decompile view is annotated immediately as we annotated the disassembly view. For now, Cutter is not supporting the annotation from the decompile view, but it's on their future list, so hope it will be ready soon. Okay, so we replaced the variable name. What we have, I want to mention one thing, that if you have quite a big function and you have enabled the decompiler widget, the processing of the decompilation of the function is really much faster than the last release of Cutter. So I really appreciate it. What we got next, you can see here some function call, and we can go to the disassembly view, and if you hover on the call, you can see some preview. Yeah, so it's quite a, you can see a preview also in the jumps. So it's quite an interesting feature. Well, we can rename the function, because if you jump to the function, go to graph view, I really prefer the graph view because it's really nice in the cutter. We can immediately see that this function is it leads to printf, so we can rename this function, pressing N, and rename it to printf. Okay, and you can see that it's renamed, and also proper type is annotated. Okay, continue. What we got next? We can check. You can basically see this is all the graph for the main function. It's quite small. What we got here, it's some last function call. If you jump to that, you can see it's jumping here, it's returning, or it's jumping here. And what you got here, another call, and this is called, yes, unhandled exception filter. So basically it's some security check. So let's annotate it or rename it in the main function, security check. Okay, and it's annotated. Well, what we got next? You can see that the main function is processing original string, printing the string, because it goes here, this goes here, and you can see it print f, yep, goes here, and printing, yep, so it's printing the original string. And next is some loop. This loop is calculating the length of the original string. You can see here that it's processing incrementing SE, so it's counting something, and you can see that the SE is pointing to the original string. So basically we can rename, or we can put a flag, press N, and put a flag name. For example, original string length calc. Okay, and you can see that the jump is annotated immediately. What we got next? We can see here is some loading of the second string. You can see that the pointer to the string is loaded here, and the pointer is loaded here. So we can again annotate it or rename this variable as pointer second string. Okay, and it's immediately annotated in the decompile view too. You check that here. Nice. What do we got next? We can again put a flag here, as for example, loading second string. Okay. Yep. What we got next? We can see here that it's jumping here or on in the end. So this is basically, you can see here immediately that it's some loop here, and basically it's our string replacing loop. which is replacing the string character by character, and you can see it here, or for example here you can put a flag again here, like string replacing loop. Okay, and you can see here that the jump is already immediately renamed string replacing loop, because what you got here, you can see that pointer is loaded, the address of the second string. Here is some calculation. Basically, this first one is calculating original string length, as we already mentioned, and this second one is calculating the second string length. So we can again put a flag here, new, yep, and we can rename it as second string length calc. Okay. What we got next? We can see here some comparing, yeah, and here is jumping to character loading. We can see that in some case it's loading the character, and in some case it's loading a null because it's loaded to AL register, and you can see that AL register is moving to this location, which is probably our original string. So we can rename this jump the flag as character load, car load. Yep, and here is the character replacing. So renamed and car or 0 replace. Okay, and we also can add some comments. Basically, we can, for example, because it's another new feature that you can see the comments in the flags view. So, for example, if we here have a flag, we can put a comment here, and we can put it like, for example, calculation of original string length. Okay, yep. And if you check the flags, you can see it here that command is populated. Nice feature. On click, you are there. And we have probably annotated what we need. So basically, it's loading the original string, printing the string, calculating its length, and jumping here, loading the second string, which will be replacing our original string. Moving forward, you can see the loop. The loop is replacing the second string characters. They are replacing the original string characters with the second string characters, and if the second string is smaller, the size is smaller, the rest of the characters of the original strings are replaced with zeros. And after this, it will jump to the final block. The final block is printing the point to the original string, so probably, yeah, it will print the replaced second string, yeah, because the location where the original string was in memory is replaced for the second string. And your security check and return and end of process. Nice. So it's our final feature introduction, and it's called reverse debugging. Basically, what does it mean? We can put some interesting breakpoints here on the main one, and we need a breakpoint, for example, here where the character replacing on starts, and put a breakpoint here, basically after each character is replaced one by one. Well, our breakpoints are set, and basically what we can jump to the preferences and go to the debug, and we can enable or disable this option, which means trace each step during continue in trace session. Basically, what it means, if you have enabled this option, you can trace, for example, from one position to second position, from one breakpoint to second breakpoint, each instruction and state of registry, state of memory, and others. And if you have disabled this one, it's basically tracing or saving the state of register and memory only on the first breakpoint and the last breakpoint and between the breakpoints. So no every instruction. It's as you hover on it, disabling this option means the stepping back after a continue will return to the previous PC significantly improves performance. Yeah, it's logical. Okay, I have enabled it because we have quite a small function. I want to trace only a few instructions. Okay, so we can start the debugging. Okay, so debug, start debugging. Okay, no command line arguments, and we are on some system breakpoint. Let's continue to reach our main function. Yeah, I already put a breakpoint here there. Yes, this I need. Yep, and switch to graph view. We are in the main function, and another breakpoint is here before the starting of replacing the string in memory. So let's continue. Yeah, we reach our second breakpoint here, and the replacing loop starts. So basically, what we can check the if you check the location of the original string, the location is basically yeah, we can go like here, put a breakpoint here, and continue. No, we are here already, so we can start the session, the tracing of the session, start trace session from this breakpoint, and we can continue. Yeah, we are in this instruction now, and we can go like this. You can check the address is EBP plus EDX minus 58 hexadecimal. So EBP is here. I want to show it in hexadecimal, and EDX is 0, and 58 in hexadecimal is quite small. We can scroll. Well, EBP, sorry, EBP is here. Show in hexadecimal, and yeah, it's here. You can see here, this is the original string, nothing special. Yep, here. And if you check that, you don't need this breakpoint anymore. Step over, step over, step over, and continue, and check that. Check this string in memory. It's replacing character by character. Continue, 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 continue. Every step it stops here on our set breakpoint, and you can see that the string is "you are fucked right now," and the rest of the original string characters are replaced with zeros. And the last one, "you are fucked right now." Okay, that's simply debugging, the stepping through the loop and putting a breakpoint here. So you have the final state, but what is the new is that you can step forward or continue backwards, like the reverse debugging. So continue backwards, and you will see what is going on here. You can see it immediately. Check this. And you can also check these registers. They are changing each step, because every breakpoint it has different state. Yeah, so the original string was replaced with the string "you are fucked now," and it's with the reverse debugging you can get the previous state when you start the character replacing loop. And you can see it here. No, cut reverse debugging saved me. And you are on the start. If you check that, you are now here. And basically it's the start of the loop. So you can, for example, stop the tracing and move forward and start the tracing again and again and again. So I think this is a really interesting feature which can be used, for example, with some decoding or encrypting function tracing, and to find out how does it work, and to basically easily write some decryptor or decoder for this routine. Well, that's quite a nice feature. I think I covered all what I want. So I want to only thank you, Rizin and Cutter, for maintaining this awesome tool and releasing these very interesting new features. Okay, thank you for watching, and see you next time.